Alright guys, welcome to lesson 4. Today we're going to be finding these things called the zeros, and basically what that means is where a polynomial will touch the x-axis. It's a useful thing to do. It helps with graphing, it helps with solving equations, it helps to actually build and write equations. So we're going to talk about how to find the zeros, the places where a polynomial will touch the x-axis. However, the problem is we're only going to be learning today how to find the rational zeros, and those are things like numbers that are nice, like numbers, for instance, like 2 or maybe 3/4. Okay, but sometimes where it touches the x-axis could be somewhere really weird, like 2.5613, blah 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 blah, and it never really seemed that's what we call an irrational number. We're only going to be focusing on how to find the rational ones, and that's just basically done through division and factoring. All right, so we're going to be actually putting together the last couple of lessons that we've learned, division and factoring, to accomplish that goal of finding these roots. So let's go ahead and take a look at our first slide here. It says the roots of a polynomial, also known as zeros or x-intercepts, are where the graph of the polynomial intercepts the x-axis. So on our picture here, these three places that are circled in yellow are the roots or the zeros or the x-intercepts of the polynomial, and that's what we're going to be trying to find today. So how do we find the roots? We're going to factor, and we're going to use something called the zero product property. And why do we care about finding the roots? Well, the main reason we're going to use it in this class is because it's going to help us with graphing a little bit. Okay, so that's what a root is. So let's go ahead and try to do this. But before we do, I want you guys to notice something. We're on the x-axis, right? And anytime you're on the x-axis, what's the y value? Anytime you're on the x-axis, the y value is 0. And that kind of tells us what our very first step is going to be when you're doing these problems. The very first step is you're going to plug 0 in for y. Plug 0 in for y. The next thing we're going to do is factor. Okay. Now our steps for factoring are, once again, you always start by taking out a GCF, and I do see a GCF here. So I can take out a 2x. If I do that, I'm going to end up with x to the 4th minus 81. And now I see that I have a difference of squares. The square root of x to the 4th is x squared, and the square root of 81 is 9. We're going to make one a plus and one a minus. So now let's see, this is prime. GCFs are always prime once they're done. This is a sum of squares. We've talked before about how sums of squares are prime, but this is another difference of squares, so we get to factor again here. All right. The square root of x squared is x, and the square root of 9 is 3. Make one plus, one minus. And now, these are no longer differences of squares. They're both just prime, and so we're done. We've factored this thing completely. All right? But we haven't found the roots yet, but that is the first step, or the first few steps. So let's review really quick. Step 1, plug 0 in for y. Step 2 is to start factoring. So GCF first, and then whatever other methods are possible. Maybe difference of squares, maybe box method, whatever. All right, so let's go ahead and start fresh here because I'm running out of space. So this is where we left off. after having completely factored the expression. Okay, well, now we're going to use something called the zero product property. Now, before I use it, let me explain it a little bit, okay? If I told you guys I have something times something, and that equals 0, what do you know? What would you assume would have to absolutely be true about either x or y? Well, if you have something times something that makes 0, that means that either the x equals 0 or the y equals 0. Because that's the only way you could ever multiply some numbers together and get 0. Well, that's what we have down here. We have actually 4 things being multiplied together. I've got 2x is being multiplied with x squared plus 9, and that's being multiplied by x plus 3, and that's being multiplied by x minus 3. So I've got 4 things multiplied together, and look what they equal. They equal 0. So the only way that's going to work is if one of these things equals 0. So either this equals 0, this equals 0, this equals 0, or this equals 0. It's got to be one of them. So we get 4 different equations because I have 4 different factors. And we're going to solve all 4 of those. And this is what we call the zero product property. Okay, so for this one, I'm going to divide both sides by 2. And I end up with 0. So there's one answer. For this one, I'm going to minus 9. And I get negative 9. And then I'm going to square root. And anytime you square root, you get a plus and a minus. When you have a negative square root, you're going to take the I out. And the square root of 9 is 3. So this is an imaginary number. Matter of fact, you don't even really have to go this far with it, because this is not a rational number, and I don't really care about this. But all that means is that this part doesn't actually give us an answer. But I'm going to go ahead and just cross it off. In other words, that particular factor does not give us an answer because we end up with an imaginary number. Let's take a look at the next one. Here we get negative 3. That's a good answer. And let's take a look at this one. Here we get 3. So we have 3 answers: 0, negative 3, and positive 3. Now that tells me the 3 places where this polynomial will touch the x-axis. Now I want to graph this just for the heck of it. This is not something that you guys have to do. But I just want to graph it and show you what we just accomplished. All right, so I'm going to type in my function here, 2x to the 5th power minus 162x. It's a really weird looking function here. Golly, doesn't even look normal. I wonder if there's a way I can reshape this thing. It's not going to let me reshape it. But anyway, we can find where it's touching the x-axis. So it's touching the x-axis here at negative 3, at 0, and at positive 3. So those are the 3 roots that we were talking about. We have to zoom really far out to see this graph. Stretch it out a little bit so that it's a little bit more normal looking. There we go. And so it looks like this, but it's very skinny actually. I just had to stretch it so that we see it normally. But there it is. That's the graph that we just ended up graphing. All right, so finding the roots. Step 1, make y equal 0. Step 2, factor. Step 3, zero product property. So this is basically factoring practice for you guys for the most part. That's where most of the work is at. So go ahead and we're going to start off together here on this one. We're going to just go ahead and do the first step together, which is let's go ahead and let's make the problems equal 0 first. And then after that, I'm going to ask you guys to go ahead and pause the video, factor these things out, and then do the 0 product property. And see if you can find the places where it would touch the x-axis. In other words, find the roots. When you unpause the video, you'll see the solution. Okay, guys, so the answer number 1 is 3. And the answer number 2 is 3. There's 3 different answers for that one. We have 0, 5 halves, and 1. So for number 3, we start by factoring it using the box method. If you did the box method appropriately, you'd get these 2 factors as a result. Now, if you set this one equal to 0 and solve, you're going to get imaginary numbers. But if you set this one equal to 0 and solve, you will get 3. So that one has only one real root, one real rational root. All right. Number 2, the first thing you're going to do is take out your GCF. Now, you might not have taken out a negative 3x. You might have just taken out a positive 3x. And honestly, it doesn't matter. You still would have gotten the same answer as me. My signs are just going to be a little bit different than you. I just don't personally like having negatives in the front, so I like to take them out in the beginning. Next, we have this trinomial, and that's a box method. So to get from there to there, we would do the box method again for our trinomial. And ultimately, you would have ended up something kind of like this. Okay. Now, once you have that, you're going to set each one of these factors equal to 0. There's 1, 2, and 3. The first one here gives you 0. The next one, I guess I'll put a check mark instead. The next one gives you 5 halves, and the next one gives you 1 when you set those factors equal to 0 and solve. Okay? So that one would touch the x-axis in 3 places. All right. So that's the first thing we'll look at today. All right. Now, let's take a look at the problem here. So this is what we just talked about, finding roots by factoring. So the first thing that we do is we take our expression and we make it equal 0. The next thing we do is we factor it, then we set each factor equal to 0, and then we solve. I want to draw your guys' attention to something here. Take note of the fact that there's a 3 here on the bottom and a 5 right here. Matter of fact, I'm going to use some color coding. That'll make things make a little bit more sense. So we have a 5 on the top and we have a 3 on the bottom. Now, where did that 5 come from? Well, it was right here, wasn't it, originally? And where did the 3 come from? Well, that's right here. Now, let's go ahead and take a look at the other one really quick. This one has a 2 on the bottom. Where did that come from? Well, it's right there. And it has a 1 on the top, which is right there. Now, why does this matter so much? Well, let's follow these numbers up a little bit. We have our 3 here and our 2 here, the 2 red ones. And then my 2 green ones, the 5 and the 1 are here. Now, it'd be nice if my pen would change color when I click on it. Grrr. Still didn't change. Nice. All right. Getting angry here. Okay. Anyway, there's that. Now, why does this matter? Well, I want you guys to notice something. That the red ones, the 3 and the 2, which are the numbers that go on the bottom of our answers, the 3 and the 2 come from this 6, don't they? 3 times 2 is 6. And the green ones, the ones from the top here, the 5 and the 1, those come from this last number over here. Okay? So what's my point in telling you this? Well, sometimes we can guess what their roots are going to be in advance without going through the entire process here. So what do I mean by that? Well, take 6 for instance. Well, I know that numbers that can divide into 6 are 2 and 3. I also know that numbers, matter of fact, I'll keep color coding here, 2 and 3. I also know that numbers that go into 5 are 5 and 1. And actually, I think I wrote them backwards. Let me back up a little bit. I'm going to put the 5 and the 1 on the top. Okay? So that means that my answers for what the roots are going to be are going to be either 5 over 2 or 5 over 3. And in this case, it was 5 over 3. And or it could be 1 over 2 or 1 over 3. And in this case, it was 1 over 2. So this is what we call the rational root theorem. Okay? So let's see what that looks like here on this next slide here. If there are any rational roots of a given polynomial, then they will consist of the factors of the first term, the factors of the last term, over the factors of the first term. You'll notice the plus and minuses there, by the way, because we don't really know what the signs are going to be. They could be positive or negative. So what this theorem is it's a theorem that will tell you what are some possible outcomes. It doesn't tell you what the answer is, but it tells you what some possibilities are. Okay? So, now, we're not going to be making much use of this today. I just wanted to share the rule with you. We are going to do an example with it, but there's a reason that we do this, and we might get to that a little bit later. But for now, let's move on a little bit. How can we tell which one of these are actual roots? Well, as you guys know, roots are where y equals 0, right? So if you take your answer and you plug it in and you actually get 0 as an answer, well, then that must have been a root. So this theorem here tells you possible roots, and if you plug it in and get 0, that tells you that possible root was actually a root. And so we're going to use that strategy here to find our rational roots of this problem. Okay, so let's go ahead and let's do the rational root theorem first. And remember, this one only tells you the possible roots. It doesn't tell you what the roots actually are. It only tells you the possibilities. Okay? Now, the rational root theorem works like this. We have our factors of the last term on the top. So what are all the numbers that could divide into 6? Well, 1 can go into 6, 2 can go into 6, 3 can go into 6, and so can 6. All right? Next, we look at the front number, the 1. What are all the possible numbers that can go into 1? Well, it's just 1. Now I'm going to put a plus and the minus in the front because, once again, the rational root theorem doesn't tell you what sign it is, so they could be positives or negatives. So here's what we're going to do now. We're going to make a list of all of our possibilities here. It could be 1 over 1. It could be 2 over 1. It could be 3 over 1. And it could be 6 over 1. And I'm not going to put over 1 because there's no point in having a denominator when it's 1. So basically, I have here 8 possible roots. So that means that either 1 is a root or negative 1 is a root, or 2 is a root or negative 2 is a root. 3 is a possible root, or maybe negative 3 is a root. Okay? Now, they're not all roots, but some real roots, some rational roots are in there. Okay? So that's the first step. The first step is to do your rational root theorem. So these are my possibilities. And there's 8 of them. All right? Well, now let's find the actual roots. Okay? The way that you do that is by plugging them in. So step 1, find the rational roots. Step 2 is plug in each of your possibilities. If it equals 0, then it's an actual root. In other words, it's not just a possibility anymore, it actually is one of our roots. Because roots are where y equals 0. So if you plug in an x value that gives you 0, well, then that must be a root. So let's go ahead and do it. Let's start by plugging in our positive 1. Now I'm going to be erasing my work as I go because there's a lot of I don't have a lot of space. But let's start by plugging in a positive one. That's going to give me 1 plus 4 plus 1 minus 6. If I add all those together, I get 0. I have a winner. So let's keep that over here. By plugging in 1, I got 0. So one of my answers is 1. Let's see if negative 1 is a root now. All right, negative 1 cubed is negative 1. Negative 1 squared is 1 times 4 is 4. All right, now if I add all those up, I get negative 8. I get negative 4. So that one doesn't make 0. So negative 1 is not a root. So I'm going to cross that one off. Positive 1 was a root, but negative 1 was not. All right, let's go ahead and see if we can find another one here. Let's try plugging in 2. And basically, you just kind of keep doing that. Now that's a little bit tedious, I understand that. But hopefully you guys got the idea. So I'm going to try plugging in a positive 2. Let's see if that works for us. We have 8 plus 16 plus 2 minus 6. That's going to be 20. So positive 2 is not a root. Let's try negative 2 and see if that works. All right, negative 2 is negative 8. That's 16. All right. Well, negative 8 and 16 makes positive 8. And positive 8 take away 2 is 6, and minus 6 is 0. So we found another winner. Negative 2 is another one of my actual roots. All right? So we just kind of keep doing that. We're going to plug in positive 3. We're going to plug in negative 3. We're going to plug in positive 6. We're going to plug in negative 6. And we're going to see if we get any more answers. Now, if you guys have a calculator, I'll show you a neat little trick at this point. And it can kind of help speed things along a little bit so that we don't spend so much time calculating all this stuff over and over and over again. So the first thing that we'll do is we will go ahead and push y equals. And let's type our function in here. X to the power of 3 plus 4x squared plus x minus 6. So you push y equals, and then you're going to enter that function in there. Okay? Next, you're going to come out of there by pushing second and quit. The next thing we're going to do is we're going to push vars. You're going to scroll over to where it says y vars. You're going to click 1 where it says function. And then you're going to click 1. And that brings up y1. And that kind of stands for your function that you just typed in. In parentheses next to it, we're going to put the next number we want to plug in. So we found, we've already plugged in positive and negative 1, positive 2, and negative 2. Let's plug in positive 3. So I'm going to type 3 in there and push enter. Now I didn't get 0, so that means that 3 is not a root. So now I'm going to bring up the y again. Now you could push vars over 1 and 1 again, but I'll show you another way to do it in a second. Now we're going to type in negative 3. Oh, we got 0. There's my other root. So I just found out that negative 3 is another root. So we have 3 roots so far. We plugged in 1, negative 2, and 3 are all roots, actual roots. Now I'm going to show you guys another way to do this on the calculator if you have one of these fancy ones here. You could just push second and then enter, and that will bring up your last expression again. All you have to do is go in here and delete what you had in there before, and type your next number. So I need to check out -6, and then I need to push second enter, and I'm going to make a +6 also. And neither one of those makes 0, so the 6's don't give me any roots. And so these are all my rational roots. Now remember, these are only the rational roots. That doesn't mean that it's all of the roots that are possible. There could be some other roots that are irrational. But what I have just found is the rational roots. Okay? All right, so that's the calculator trick. So if you have a calculator, it could make life a little bit easier. If you don't, well, just go ahead and do it by hand. It's not a biggie. I don't plan on giving too many questions like that on the exam. And when I do, I'll give you a hint about which ones to even try working on. But anyway, there's a step. So what did I do first? The first thing I did was I used the rational root theorem to find the possibilities. And then after that, I plugged them in to find all the ones that make the equation equal 0. And those ones are the ones that are actually the answers. So we should probably do a guided practice for this one before we actually ask you guys to do a student practice. So let's do a guided practice. So step 1 is to find all the rational roots. I'm just going to abbreviate it RR. All right, so what are the numbers that I'm going to put on the top? Pause the video here and see if you could find the numbers that go on the top. The numbers that go on the top are all the numbers that could divide into this last one, which are 1 and 3. Now, what are all the numbers that I'll put on the bottom? I'm usually going to keep it easy on you guys, but in this case, it's a 1, so that's all you could put there. So now, what are my possible roots? Go ahead and see if you could list all those out. 1 over 1 and 3 over 1. And once again, don't forget, they could be positive or negative. So we have 4 possible roots. A positive 1 and a negative 1, or a positive 3 and a negative 3. Now we need to figure out which ones are actual roots. And that's where you basically just plug them in and see which ones end up making 0. So pause the video here and plug in those 4 numbers and see if you can find out which ones are the actual roots. All right, so it turns out that the only 2 that when you plug them in give you a 0 are the numbers 3 and 1. Okay, so now here's 2 other ones. The one on the left, there's another basic example, just kind of straightforward. The one on the right, a little bit tricky because now we have a number in the front that's a little bit different. Matter of fact, I think I'm going to change it again. All right, there you go. I changed it. Sorry about that. And what's going to be different about this is that you're going to end up with 2 numbers on the top and 2 numbers on the bottom. And I want to see if you guys can figure out all your possibilities. So go ahead and pause the video here and see if you guys can find the possible roots, and then see if you can also find the actual roots. When you unpause it, you will see the solution. And here are the answers to these. Now, the first one's pretty straightforward. You just have these possible roots of positive -1, positive -2, positive -7, and the only one that's a rational root is -2. None of the other ones give you 0 when you plug it in. This one over here, though, you have quite a few rational zeros. But let's talk about how to get those possibilities, because that one might have thrown you a little bit. Let's see. So we start by finding what are all the numbers that multiply to make the top. And that's what goes on the bottom. Now, the only things that go into 3 are 3 and 1. Same thing over here, 3 and 1. But we have a lot of possibilities. I could do 3 over 3, or I could do 3 over 1, or I could do 1 over 3, or I could do 1 over 1. There's a lot of possibilities, but actually some of these possibilities are really just the same thing. Like this and this, they both equal 1. This can be simplified to be just 3, and this is 1/3. And as you know, they could be plus or minuses. Okay, so there's my possible roots. Then you have to go through the work of plugging in all 6 of those possibilities into your original equation to see which ones actually end up making 0. And it turns out the ones that will make 0 are -1, -3, and 1/3. So there you guys have it. That's our lesson for the day, and we'll see you guys next time.